Hi all, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So today in this video lecture series, let us see about Kirchhoff's voltage law. So in general, circuits must be analyzed to determine the complete sets of voltages and currents. So we have two types of Kirchhoff's law, which is Kirchhoff's current law and Kirchhoff's voltage law. So they are simply the restatements of charge and energy of conservation. So today we will see about Kirchhoff's voltage law in this video. So before going into Kirchhoff's voltage law, we need to know some basic definitions of electric circuit. First one is a node. So a node is a point at which two or more elements have a common connection. Next one is path. So if no node is encountered more than once, then the set of nodes and elements that we have passed through is defined as a path. Next one is loop. So if the node at which we started is the same as the node on which we ended, then that path is known as a loop. Next one is branch. So branch is a single path in a network composed of one simple element and the node at each end of that element. Thus a path is a particular collection of branches. So next one is, we will see the definition for Kirchhoff's voltage law. So it's the algebraic sum of voltages around any closed path is 0. So we can say that V1 plus V2 plus V3 plus etc. up to Vn is equal to 0. So the algebraic sum of voltages across the individual elements around it must be 0. So we can represent it as compactly as summation of n is equal to 1 to n, Vn is equal to 0. So consider you are having three components 1, 2 and 3 whose voltages are V1, V2 and V3 as shown in the figure. So if we carry a charge of 1 coulombs from A to B through element 1, the reference polarity signs for V1 shows that we do V1 joules of work. So if we choose to proceed from A to B via the node C, then we expand V2 minus V3 joules of energy. So the work done, however, is independent of the path in a circuit. So we can tell V1 is equal to V2 minus V3. So another method of applying KVL is moving mentally around the closed path in a clockwise direction. So writing down directly the voltage of each element whose positive terminal is entered and writing down the negative of every voltage first met at the negative sign, we can write the equation for this single loop as minus V1 plus V2 minus V3 is equal to 0. Since entering is negative sign for V1, it is minus V1. So then entering is positive sign for second one, it is plus V2, and for the third one also the entering is negative sign, it is minus V3. So consider this example shown here. So in this circuit there are 8 elements. So find the voltage across the R2 and the voltage labeled as Vx. So in order to find the voltage across R2, first we need to write the loop equation. So here we can write the loop equation as shown here. So we find VR2 by writing KVL equation around the loop on the left starting at point C. So if you see here, the first loop will be getting, we are having 4, 36 and R2. So you can write it as 4 minus 36 plus R2. For 4 entering is negative, for 4 entering is positive, so it is plus 4. For 36 entering is negative, so it is minus 36, and be writing it as VR2 is equal to 0. So which leads to VR2 is equal to 32 volts. So we have found out VR2. Next we have to find out Vx. So in order to find out Vx, we need to apply KVL beginning at point C, moving up and across top through Vx to B and through conducting lead to the starting point. We will be taking the maximum loop. So we will be getting plus 4 minus 36 plus 12 plus 14 plus Vx is equal to 0. So we will be getting Vx is equal to 6. Or else you can take the second loop alone in this circuit and you can write it as for finding Vx. See here, you will be having 12 volts and 14 volts. So you add both, so you will be getting 4 plus 2 6, so you will be getting 26 volts again. You can write the equation for this second part alone, which is this. Okay. So next one will be getting minus 32 plus 12 plus 14 plus Vx is equal to 0. So here also Vx will be equal to 6 volts. So hope you understood KVL. So let us take some assessment questions. So KVL deals with the conservation of the options of mass, momentum, charge and energy. So KVL always deals with energy. The sum of the voltages over any closed loop is equal to the options are 0, infinity, 1 volt and 2 volt. So always the voltages over any closed loop is 0. So what is the basic law that has to be followed in order to analyze the circuit? So the basic law that has to be followed is Kirchhoff's law. Thank you for watching this video.